Welcome all. This is Ashok Kumar Sarvepalli. In the previous two sessions on mensurations, we just saw about shapes, 2D shape, 3D shape, and finding volumes, total surface area, and so on. In real life or real time, we see the combination of solids, not a cube separately or a cylinder separately. They are also available, but most of the solids are combination. So typically, you will end up in finding what is the surface area, volumes, and curved surface area of these solids. So this session is I'm going to give a picture about. I'm not going to solve any problem. I'm going to give an idea how to approach to finding the curved surface area, total surface area of the combination of solids. Okay, fine. So now I'm going to show the first combination. Like there are many type of combinations that can be made available naturally. What if we place a hemisphere on top of a cylinder, or hemisphere on bottom of a cylinder, whatever it is. So I have a cylinder. It's a cylinder. What if I place a hemisphere on top of it like this? What does it mean? So when I show here, you may not picturize that much. So I will show you the diagram. So what about this type of figure? You have a hemisphere. It's loading. Yeah, so you have a hemisphere at the bottom. You may wonder, this is a cylinder, it's a test tube, right? This is a cylinder till this part. In the bottom, if you see, it is not a cylinder in the bottom. The entire thing is not a cylinder. In the bottom, if you could see, this is a hemisphere bounded on the cylinder. As how a cylinder will be, the entire thing will be straight. But here, a hemisphere bounded. Okay, so this is a hemisphere at the bottom. So here is a sphere. Now what is the amount of paper you require to cover this entire test tube? Suppose I want to present this test tube to someone. So what is the amount of paper you could see that I could require, the amount of paper, or what is the surface area I need for this combination of solid? Yes. So in this type of solid, if you see, it is a test tube, right? So you have something like this. It's a cylinder, and in the bottom you have a hemisphere, right? So now till the cylinder is curved surface area you need to take of the cylinder. Reason, you are not going to cover the top circle or the bottom circle, because in the bottom it is covered by the hemisphere, in the top it is open in the test tube. So the total surface area is nothing but the curved surface area of the cylinder, which is nothing but 2 pi RH, curved surface area of a cylinder, and curved surface area of a hemisphere. Also the circle of the hemisphere you will not be coating, because the hemisphere is like this. Only you want to paint like this. This is open, right? So that will be curved surface area of hemisphere again. So what is curved surface area of hemisphere? Which is nothing but 2 pi r square. So this is the total surface area, the total paper that you require to cover this entire test tube. So basically what you need to see is whether I need to use curved surface or total surface. As I teach you in the previous class, the combination of solids is very important. The formula how each and every solid came is also important. By that only you will know, if you don't cover the top and bottom of a circle, it's 2 pi RH. If you don't cover the circles, hemisphere's circle, it is 2 pi r square only, right? So then it is 2 pi RH plus 2 pi r square will be the combination of that solid. Now we will do one more thing. Yeah. So now coming to the next solid. See this solid. So this is a cylinder. And again, in both portions, if you see here in this figure, in both portions you have a hemispheres covered. So this is a natural occurring type of thing, a rod, right? Rod covered with the hemispherical ends. Okay, so how will you find for this? So for this type of thing, you will see that it is basically like this. It's a cylinder, and but here and here it's a hemisphere covered, right? So when you cover what is the total surface area, the amount of paper that required to this is, you will cover the entire cylinder excluding the top and bottom, because top and bottom you have a hemispheres. So the curved surface area of a cylinder again plus curved surface area of a hemisphere twice, if both are of same radius. So basically if the hemisphere and cylinder of same radius, then only this combination is possible. If you see, because I have a cylinder like this, on top of it if I place a hemisphere, both should be the same radius, then only the combination will look good. So this will be 2 pi RH plus CSA of a hemisphere 2 pi r square plus another hemisphere, this one plus another this one. So this combination will give you the total surface area of the solid. Fine. Then what about volume? Volume is the amount of water filling. You need to add everything. Volume of hemisphere plus volume of cylinder plus volume of another hemisphere. Okay? Yeah. We'll see another one. Yeah. So next is, see here, it's a tent. So what is the shape? Tent. Surely it is not a hemisphere on top of a cylinder. The base of the tent is a cylinder, and here it is a cone. We assume this cone is exactly fit into the radius here. So in that case, this figure, how will you find the total surface area, the sheet required for the tent? Yeah. So this is a cylinder you had, and on top of it you had a cone typically, right? So that is what the diagram I have shown, right? So in this case, what you need to do is, you need to typically find the total surface area. Means what you will do, total surface area in the bottom of the tent is a ground. You will not cover the circle in the bottom, that is a tent. You will not cover for that. And in the top, if you see in the cylinder, so it's nothing but 2 pi RH will be the curved surface area of the tent, length the curved surface area of a tent. Here it will be open, right, in the tent. So it will be pi RL. So it's sort of a cylinder, it's sort of a cone. Fine. Again, their both radius will be same. Fine. And now see here, this one. Again the same example. A cylinder on hemisphere. See here, many examples here. This is a cylinder on top of hemisphere. So cone separately, your top. This one, your cone, and on top of it a hemisphere. This is a top we used to play, right, in our childhood days. So see that figure, your top, on top of it you have a cone, similar to your cone eyes. So this is nothing but curved surface area. You need to put pi RL plus the curved surface area of the hemisphere, which is 2 pi R square. Reason? Yes, this circle you will not be able to cover. Entire outer only you will cover. That is a typical reason. Yeah. And now, see these type of shapes. This again the same thing we discussed and so on. So this is how you need to combine the solids basically. When you put a circle on top of a cube, what gonna happen? Will it fit it correctly on top of a cube? When you put a hemisphere on top of a cube? No. If you put a hemisphere on top of a cube, you will have some gap. Okay, you need to consider in these type of problems how much is the gap. So in the top of the cube is a square, and the base that it is touching is a circle. So you need to minus the area of the circle, area of top square minus area of circle will give you the remaining portion in the, when here hemisphere is placed on the top of a cube. Fine. Okay. So I hope it helps. And then from the next class, what we're going to do is, we're going to solve the problems. There are about a set of problems here. We're going to solve this. Around 14 problems are there. We're going to take 3 to 4 sessions to complete this. Thanks for watching.